Hi guys, in this video we're going to have a look at proof and some of the really wordy questions that we associate with it. So, let's read this one. It says, show algebraically that the sum of three consecutive, and I nearly missed this word out, even numbers is always a multiple of 6. Now I started doing this and you can see here I crossed it out because I didn't see the word even and that didn't work. So I went back, it said even, so now it makes more sense. So with proof, what we need to use to get to think about is what expression will always create an even number. Now, if you have any number and you times it by 2, that therefore would create any even number. So this is the expression that we give for any even number. So algebraically, it means use algebra, and this represents an even number. Now, so let's understand the question. So if I take a 2, the next consecutive even number would be 4, the next even number along, and the next one after that would be 6. And if you do 2 add 4 add 6, you get 12, which is a multiple of 6, but we have to prove it algebraically. And it doesn't matter how many times you do this numerically, you need an expression to show that any number will work, not because you'd be there for infinity writing numbers out. That's why we have algebra. So if this is our first even number, you'll see to get to this one we had to add 2 to this one. So the next one is going to be 2n plus 2. And then the next one would be 4 more, or 2 more than that one. So you can add 2 to this one. So this is our expression for our first even number, our second even number, and then our third even number. And if you collect these like terms, you will get 6n plus 6. Now if something's a multiple of 6, it means we can then factorise this for 6 to show that 6 always goes into it. So this equals 6 brackets n plus 1. This is what we're trying to do. If it's a multiple of 6, we can factorise for 6, which we can. Let's have a look at another one. So now we have the sum of 2 consecutive whole numbers. So this isn't even or odd. So let's have a look. So if we take 2, the next consecutive number is 3. And if we add those, it's 5, and that's what we're showing. So we'll take exactly the same approach. Look, even if you start with an odd, 3 plus 4, that's 7. So it definitely works. So let's start with this one. So it's an even number plus an odd number. Now, if this is even, to get an odd, you add 1. So this must be our expression for odd. Now, this gives us 4n plus 1. Now if something is even, it means it's in the 2 times table. So what you can say is this can't be factorized in the form two brackets. You can write something like that, because if it can't take a 2 outside, that means it's not in the 2 times table and therefore odd. Or you could write 4n plus 1 cannot be divided by 2 and therefore odd. Something along those lines, just to say that hasn't got a 2 as a factor. Look at some slightly trickier ones. So this is a tough one. So the difference between the squares of any 2 consecutive numbers is equal to the sum of these 2 integers. So again, let's take 2 and 3. So we're saying the difference between these squares, so 2 squared, so that's 4 and that's 9. So the difference between them is 5. And that should equal the same as these 2 initial numbers. And it does. So we can prove numerically that this works, now we have to prove it algebraically. So to find the difference, it's always the biggest take the smallest. So we're going to start with this one. So this is an odd number, so I'm going to say, well, 2n plus 1, and we're squaring that. And then we're going to take away our even number, and we're squaring that. So, square means times by itself, so actually what we have is this. Take away 2n times 2n. So, expand the bracket. I'm going to do this quickly. So it's 4n squared plus 4n plus 1, and this one is 4n squared. Now if you see here, 4n squared take away 4n squared, these actually cancel themselves out and we are left with 4n plus 1. So that's what happens when you square them and take them away. Now, what happens when we find the sum of these expressions? Remember, these are the starting odd number and even number. Now, let me just move this up. If I add these together, it's 4n plus 1. So we're showing that both ways we get the same algebraic answer, and therefore they are equal. That's all you have to do. Now, sometimes they ditch all the words and just give you the algebra. So we're having to show that this is a multiple of 8 for any positive value for n. So that doesn't mean pop numbers in. It means prove algebraically. So we're going to do pretty much the same as what we just did. So squared means times by itself. So let's go ahead and do this. So that's 4n squared. 6n, another 6n is 12n plus 9. Now this is where, excuse me, it starts to get tricky. And I'll show you why I'm putting brackets around this in a second. So 4n squared minus 6 minus another 6 is minus 12n plus a 9. Now the reason I put brackets here is because it's this take away this one. So it's all of this take away all of that. Now if I don't put the brackets, I always make the mistake of just putting this negative with this term, but we're actually taking away all of this. And let me show you. So it's 4n squared take away 4n squared. That's going to go. But it's 12n minus 12n. So the double negative creates a positive. So that is actually 24n. And 9 take away 9 is a positive. So 9 take away 9 is nothing. So we end up with 24n. Now to prove that this is in the 8 times table, we have to show that this has a factor of 8. So 24n is 8 times 3n. Because we can show that it's 8 times something, it is in the 8 times table. And there you have it. There's all the different proof questions pretty much. So just get practice in, but they're always the same.